Hi all, welcome to Security and Privacy in Cloud, and I'm Lavanya, Assistant Professor of CSE Department. So today we are going to discuss about the topic on hash function, authentication, and digital signature. Let us dive into the topic. So the first one is that hash function. You know, hash function is nothing but it's a fundamental concept in computer science and it plays a crucial role in various applications such as data storage, retrieval, and cryptography. In data structures also, hash functions are primarily used in hash table, which are the essential for efficient data management. So here we are going to discuss about the hash, and it is a one-way function with a properly designed algorithm. There is no way to reverse the hashing process to reveal the original input. Compared to this encryption, that is two-way function, which allows encryption and decryption the corrected key or keypad. Another specific use case of hash function is in data structure like hash table or blue filter. So the goal here is not security but rapidly data hookup. Now, the requirements of a cryptographic hash function. So let us see what are the requirements. The input can be of any length. The output has a fixed length and the hash function is relatively easy to compute for any input. The hash function is a one way, that is nothing but is extremely hard if it is not impossible to determine the input from the output. The hash function is collision free and there can't be two different messages producing the same hash value. And if you take the key properties of hash function, it is deterministic, fixed output size, efficiency, uniformity, pre-image resistance, collision resistance, and avalanche effect. So what is meant by deterministic? So deterministic is nothing but a hash function must consistently produce the same output for the same input. And what is meant by fixed output size is nothing but the output of a hash function should have a fixed size regardless of the size of the input. Efficiency is the hash function should be able to process the input quickly. And what about uniformity is nothing. The hash function should distribute the hash values uniformly across the output space to avoid clustering. And the next is the pre-image resistance. Here, it should be computationally infeasible to reverse the hash function, and that is to find the original input given a hash value. Collision resistance. It should be difficult to find the two different inputs that produces the same hash value. So, and the next is that avalanche effect. A small change in the input should produce a significantly different hash value. So next topic we are going to see is about the SHA algorithm, which we have seen already in the previous video. If not, you can just go through that particular video. So SHA is nothing but consists of SHA-1, SHA-2, SHA-3, and also it's a government standard hash function which is promoted by the National Institute of Standards and Technology. And here it contains SHA-1, SHA-2, SHA-256, SHA-224, SHA-512, SHA-384, and SHA-3. The SHA-1 that is takes as a virtual any length of it produces a 160-bit message. It produces a message in 512-bit blocks. The message isn't a multiple of 512-bit. The SHA algorithm pads the message with data until the length reaches the next highest multiple of 512-bit. Next is that SHA-2, which was published in the year 2001. And it's a reaction to the weakness of the SHA-1, that is, it has some advanced facility that includes significant changes from its predecessors, and it has four major variants. That's coming under the SHA-2 version. It has SHA-256, SHA-224, SHA-512, and SHA-384. And SHA-3 was published in the year 2015, which is the same series of standards, and SHA-3 is internally different from the MD5 like structure, and SHA-3 is a subset of a broader cryptographic primitive family. So this is all about some SHA function, which was discussed in the previous slide. And SHA, it has some input and it produces the hash function based on some hash value. So this is all about SHA. And if we take the applications of hash function, the first one is the hash table, second one data integrity, third one cryptography, and fourth one data structure. So what is meant by hash table is that the most common use of hash function in DSA is hash table, which provide an efficient way to store and retrieve data. And data integrity is nothing but is a hash function that is used to ensure the integrity of data by generating checksum. Cryptography. So cryptography in cryptographic applications, the hash functions are used to create secure hash algorithms like SHA-256. And next one is the data structure. Here, the hash functions are utilized in various data structures such as Bloom filter and hash set. And next is we are going to see is about the types of hash function. So these are the types of hash function. First one, division method, multiplication method, mid square method, and folding method. So let us discuss about one by one. So first one is nothing but the division method. This is the most simple and easiest method to generate hash function. The hash function divides the value k by m and then uses the remainder update. So h of k is equal to k mod m. So here k is the key value and m is the size of the hash table. Say for example, if I'm giving the k value as say we can give us some 25. Okay, if I'm giving 25 in the sense, and if suppose m value is what is this? So mod is nothing but you have to choose the remainder. So that's it. So called as a mod. So if I'm giving m as 5, okay, I think you're able to see the lines. Okay, so if 25 mod 5, so what will be the value of h of k? You'll be getting as 5, right? So once h of k is equal to 5 in the sense, you have to just put on the hash table. So 5 in the sense, the size may be vary from 0 to 4. So in that time, 0, 1, 2, 3, 4, you have to pick it on and you have to save it on the 0th index. So this is about the division method. And next one is that mid square method. But one more thing I want to say about the division at the previous slide. In division method, the advantage is that it's simple to implement and it works well with the prime numbers. But the drawback of the division method is that poor distribution if the particular value, that is the mod value, is not chosen wisely. Okay. So next is that the mid squared method. So the mid square method is a very good hash technique. It involves two steps to compute the hash value. So the first one is that square the value of the key, that is k2. Second one, extract the middle digits of the hash value. The formula is then h of k is equal to h of k into k. So this is the formula for mid square method. And here k is nothing but the key value. And in this mid square method, the key is squared and the middle digit of the results are taken as the hash value. Okay, so if you are, for example, if I'm giving us 2 in this is 2 into 2, you'll be getting us 4, right? The 4. Here the hashed value will be fixed as the hash key size. Okay, so this is what we'll be following in the mid square method. And the advantage is that produces a good distribution of hash value. A drawback is that it may require a more computational effort. So this is all about mid square method. Next one is that digit folding method. So here also it involves two steps. So the first step is that we have to divide the key parts and you have to sum up the parts. And next one, we have to take the modulo m of the sum. So folding method, it involves dividing the key into equal parts, summing the parts, and then taking the modulo. with respect to the modulus value. Okay, so this is about the digit folding. And if you take the advantage, that is it's simple and easy to implement. And the drawback is that depends on the choice of partitioning scheme. And here also, if we take, we have to add the individual parts. The hash value may be obtained by getting the last with this k is equal to k1, k2, k3, k4 till the kn value. Okay, and s is nothing but k1 plus k2 till kn. H of k is equal to yes. So yes is obtained by adding the parts of the key k. Okay, so this is called as the digit folding method. And next we are going to see is about the multiplication method. So here in this multiplication method, we have to choose some constant value. Okay, these are the steps. First, we have to choose some constant value. Say, for example, 0 less than a or less than 1. So this is what we have to follow. And then we have to multiply the key value with that particular a. And next is that we have to extract the fractional part. So k of a. And next, we have to multiply the result of the above step by the size of the hash table m. And next, that is the last one, is that the resulting hash value is obtained by taking the floor of the result which is obtained in the previous one. Okay, so that is what. So once you have got the step 4, based on that we can able to multiply. So this is all about multiplication method. So next one is that this is a formula which follows for the multiplication. So h of k is equal to floor m of ka mod 1. Okay, the formula is that m is nothing but the size of the hash table, and k is nothing but the key value, and a is nothing but constant value. So this is a formula to be followed for multiplication. And next one we are going to discuss is about digital signature. In this digital signature, there's a mathematical technique, which is used to validate the authenticity and integrity of a message, software, or a digital document. There are some of the key features of it. The first one is that the key generation algorithm. So key generation algorithm is nothing but the digital signatures, which are electronic signatures. Here, we will be assured that the message was sent by a particular sender, and while performing some digital transactions, authenticity and integrity which should be assumed. Otherwise, the data can be altered, or someone can also act if he or she was the sender and expect a reply. And next one is the signing algorithm. The signing algorithm is nothing but to create a digital signature. Signing algorithm like email programs create a one-way hash function of the electronic data which is to be signed. The signing algorithm that encrypts the hash value using the private key or the signature key. This encrypted hash along with other information like the hashing algorithm is the digital signature. This digital signature is appended to the data and sent to the verifier. The reason for encrypting the hash instead of the entire message or document is that a hash function converts any arbitrary input into a much shorter fixed length value. This saves time, and which is very much faster when compared to the other signing methods. And last one is that signature verification algorithm. So the signature verification algorithm here, the verifier receives a digital signature along with the data. It then uses some verification algorithm to process the digital signature and the public key and generate some value. It also applies the same hash function on the received data and generates a hash value. If they both are equal, then the digital signature is valid. Else, it is not valid. And here also, if you take, we can implement means of two calls, that is a digital measure as is a recipient and a message came from the client sender. This provides a non-repetition. And next one is that a digitally signed message provides the recipient the assurance that the message was not altered while in transit. This protects against malicious or unintentional modification. And the last point is that the digital signature rely on the combination of two concepts, public key cryptography and hash functions. So here you can see the diagram. So what are the steps I've just followed here? The first, what they have done is that message digest is computed by applying the hash function on the message, and then the message digest is encrypted using the private key of the sender to form a digital signature. So here you can see the diagram. And once the private key of the sender to form a digital signature. So here, after that, the digital signature is nothing, the encryption of the private key of a sender. So here they have mentioned the private key. You can comma the message digest. So what digest hash function has been used. Along with that message digest, you'll be using some message digest algorithm, that's MD5 or SHA, something like that. And once the second step, a digital signature is then transmitted the message. And the third one, the receiver. So this is our receiver side. So in the receiver side, it decrypts the digital signature using the public key of the sender. This assures authenticity as only the sender has this private key. So the only the sender can encrypt this by means of private key, right? So this can be decrypted by the sender's public key. The receiver now has the message digest value. The receiver can now compute the message digest from message. The message digest is computed by the receiver, and the message digest need to be same for ensuring the integrity. So if you want to calculate the integrity process in the sense from this both sender as well as receiver, it should be equal. So this is all about the particular diagram. What are the assurance of digital signature is that authenticity, integration, non-repudiation, and notarization. We all know about the authenticity, integration, non-repudiation. So what is meant by notarization? So notarization is nothing but under some conditions, a signature in a Microsoft Word or a Microsoft Excel or a PowerPoint, that has been timestamped by a secure timestamp server, which is equal to a notarization. Okay. What are the assurances? So this is what I have explained now: authenticity, integration, non-repudiation, and notarization. And if you take the benefits of draw signature, before going to the drawbacks, let us discuss about the benefits. Legal documentation and contracts, sale contracts, financial documents. The last one is nothing but health data. Then the first one, legal documents and contracts here. The digital signature are legally binding. This makes them ideal for any legal document that requires a signature authenticated by one or more parties and guarantees that the record has not been altered. Second one, sales contracts, digital signing of contracts and sales contracts authenticates the identity of the seller and the buyer, and both the parties can be sure that the signature are legally binding and the terms of the agreement have not been changed. A financial document, if we take the finance department digital sign invoices, so customers can trust that the payment request is from the right seller and not from a attractor trying to trick the buyer into some selling payments to fraudulent account. And last one, health data. So health data is nothing but in the healthcare industry, privacy is paramount for both patient record and research data, right? So digital signature had to ensure that such that this confidential information was not modified when it was transmitted between the consulting parties. So here in this drawback, the first one is the dependency on technology. So dependency on technology is nothing but because digital signature rely on technology, they are susceptible to crimes, including hacking. As a result, businesses that use digital signature must make sure that their systems are safe and have the most recent security patches and upgrades installed. And second one, the complexity. So we have normal in the C program we using the term complexity, time complexity, space complexity. So similar to that, here also we are having some complexity. First, you have to set up and use the digital signature, which is challenging especially for those who are unfamiliar with the technology. This may result in some blunders and errors that reduce the system efficiency. The process of issuing a digital signature to senior citizens can occasionally be challenging. And the last one is that limited acceptance. So limited acceptance here, the digital signature can take time to replace manual ones since technology is not widely available in India, right? Our developing nation. But if you take go for US or UK, that they have used this type of limited acceptance technology. And the next is we are going to discuss is about the authentication. So here in this authentication, confirming that the user is who they say they are, then shows what type of authorized credential they are giving, and make sure that only the particular people has to use the system. And is in a simple term we can say like a process of verifying the identity of a user or device before allowing them to access a system. For example, if a user attempts to access some information or in a network, they provide secret credentials to provide the identity, like username, password, or biometric authentication, or Mac message authentication code, or one-time OTP. All those things comes under authentication. So authentications allows you to grant access to the right user at the right time with the confidence. Uh, authentication is a part of a three-step process for gaining access to digital resources. So these are the three steps. The first one, identification. So whether the particular person is, by means of, for example, if you're working in a company, they'll be giving some unique company ID, right? So who are you? So that is identification. Second, authentication. Okay, so once you have entered the particular industry or the company in the sense, you want to authenticate yourself by going to a website. You have to give your name and your password, all those things, and you will be authorized. I mean, you'll be authenticated. And the uh, last step is that authorization. So here, okay, once you have authorized by means of proper thing is that you can go for the have permissions and you can go for the access. So this is all about authentication. And apart from authentication, we can go like in cryptography, we'll be having so many authentication steps, right? uh, so what are the types of authentication? We see that the single factor authentication, two-factor authentication, and three-factor authentication, and multi-factor authentication. So let us see one by one. So the first step is that single factor authentication. Single factor authentication is nothing but this was the first method of security that was developed on this authentication system. The user has to enter the username and password to confirm whether that user is logging in or not. If the password or the username is wrong, the user will not allow him or her to log into the system. The advantage of using the single factor authentication is very simple to use and it's straightforward, and it is not at all costly. Okay, and the user does not need any huge technical skills. And drawback is that it is not all password secure. It will depend on the strength of the password entered by the user. The protection level in single factor authentication is very, very low or less. And next is about the two-factor authentication. Two-factor authentication here, in this authentication system, the user has to give a username, password, and other information. So there are various types of authentication system that are used by the user for securing the system. Some of them are wireless token or virtual token, OTP, and more. Advantage is that the two-factor authentication, it provides better security than the single-factor authentication. And second one, the productivity and flexibility increase in the two-factor authentication system, and it prevents the loss of trust. But the only drawback is that it's time-consuming process. And the third one we're going to discuss is about the three-factor authentication, or multi-factor they used to say. Three-factor is also combining the single factor versus the two-factor authentication. By combining both the authentication, we can be able to predict the three-factor. And the last one is that multi-factor authentication. So in this multi-factor authentication, more than one factor of authentication is needed. This gives a better security to your user. Any type of keylogger or phishing attack will not be possible in a multi-factor authentication system. The advantage of using the multi-factor authentication is that no risk of security, no information could get stolen, no risk of any keylogger activity, and no risk of any data getting captured. The drawback of multi-factor is that it is very time consuming because it was so many multi-factors, right? So that is one drawback. A second one is that it can rely on third parties. Third parties, like suppose if OS is using some identify or authenticates by means of password, physical identification, and biometrics. By means of that, we can able to see the multi-factor option. So this is all about the types of authentication. So we have discussed about the hash function, authentication, as well as the digital signature. Okay. So these three are mainly involved in cloud security process, because without this, we can't able to go further. So thank you all for watching this video. Thank you.